Thank you for joining my show, and today we're going to be talking about the McDonnell low water cutoff. This version here, that I think it's been updated a couple of times, but it worked pretty much the same. This particular unit is a 24 volt type, uh, automatic reset. You got a test button here, you've got a green power LED, and you've got a red low water indicator. There is no manual reset. The manual reset button would go in that knockout there. The cover is now made out of plastic. Earlier versions were metal, and this particular one is the PS802U 24 volts. The U refers to the type of probe that's going to come with it, which is this extra long one here. This is an example, an older example. The ones that usually come, the non-U versions, are the relatively short ones, 3/4 inch tap, and we'll get into that a little bit later. This is the self-cleaning feature, that dongle that as it vibrates as the water is boiling helps keep this from crudding up. And I think they have a PSE version, and then they have even a newer version, which might make a video on that later. This is the schematic. Help you wire it. A little difficult to get a picture of it. And this is the blink code on the lights, which we'll show you in a bit. So this is the wire that would normally go to the probe, and the probe comes through here like so. You've got these screws, which you want to back them out a little bit, and this is mounted on the boiler, and the control then mounts through those screw holes there, like that, and then you tighten them down, and then the probe wire goes on the end of that terminal. And there's usually a wing nut. You've got to take the probe wire off, the wing nut off, in order to get the this unit off of the probe, like so. And one tip, I would back these screws out, put them on anti-seize, and if you need to remove the probe, I would run these screws all the way in, because when you put a wrench on these things, there's not a whole lot of metal, and this tends to get mushed. The new modern later versions of this probe is only half as thick as this. Is even more likely that that's to happen, so be aware of that. That'll save you a lot of heartache. Somewhere on these printed circuit boards will have the voltage that it operates at. And you can see there it's 24 volt AC input. Other manufacturers don't do that for you. This is the Molex clip-on for when you're running a package boiler. The wiring harness goes in there, and generally the screw terminal strip is used for wiring up the automatic water feeder. So you've got that's marked neutral, hot. You've got a jumper here, which is removable, and then you've got a common, so the hot goes to common, and then you've got water and the burner circuit. So we can put some pilot lights here to act as visual aids to see how this is supposed to operate, and that's what we're going to do. So I'm going to run this wire in there, And this then, since it's green, we're gonna twist those wires together there. We're gonna use this on our water circuit. This is the W is the trigger for the water feeder. And we got, thank you there, we'll get that. And then this is gonna be the amber light, 24 volt, we're gonna run it on the burner circuit. I'm gonna wire it to here under the B. And both of these wires are then going to go under the neutral or return circuit. Give me a minute here. Thank you for bearing with me. Hope you can see all this. It's hard for... Yep. Messing up here. Again, thank you for your patience. Really screwing up. Stranded wire, gotta love it. All right, I think that's gonna be good. We'll know in a minute. And I'm gonna wire this 150 ohm resistor to the ground screw here, and you'll see why in a few minutes. Make sure we got this squared away. There we are. There we go. So let's tape these down, make them look nice. There we are. Hope we can see that. Let's move the camera. Let's tilt this up. Now we want to be able to see the, nope, that's not going to be good. You want to be able to see the power lights there. There we are. Okay, let's move this over so I can see it. There we are. Thank you. All right. So I want you to be aware that the printed circuit board, or portions of it, is actually bonded to the case. I'll show you that in a minute. You see these brass terminals, which then are riveted to the case there. 1, 2, the 4 of them are riveted. And they go to these screws here, which are wired up to the printed circuit. And that allows this portion of the probe, which is insulated from this portion of the probe here, this rod, to only be able to be connected with the water, which would go from here, this surface, and the threads and the boiler and so forth, to this portion, which is inside the water. But we're not going to even hook this up to a probe. We're not even going to have any water at all. We're just going to wire this up to show you what should happen. So we're going to put one terminal, 24 volts, to the hot, and we're going to put another terminal to the neutral, the unswitched leg. I think we can see that. There's our resistor there. And we're going to power it up. Now what should happen is the green light and the red light are going to blink, and then the power light is going to then stay solid, and the low water cutoff is going to, low water indicator is going to blink. What also should happen is the green light should come on, which is the default setting, which means this is going to be sending a signal to the water feeder. So this is going to go solid, and that's going to continue to blink a couple of times, and then it's going to go solid, and then it's because it's detecting no water. All right, so burner circuit is off, water feed circuit is on, and we're not hooked up to any probe or any water or anything. So let's touch the end of the probe to the case, which is bonded to the printed circuit board to complete the circuit. I'm touching it on there, and you'll see an interesting phenomenon. The power and the low water lights are blinking alternatively, which means, yes, you are grounded, but it's such a low resistance pathway that it is tricked. We know it's being tricked. And so that is a way of preventing accidental or sometimes not accidental shorting out of the probe in order to get the burner to fire. The burner circuit, as you can see, is not energized. So what we need to do is we need to run this probe circuit through a resistor or some resistance so that it thinks that it's actually attached to water. So here we are. That's why we've got the resistor here. We're going to put the probe on the terminal, and now that's going to blink a couple of times to make sure it's a stable signal. Delay on make, as they say, DOM. And now it's going to go off, and the burner circuit is going to come on, and the water circuit's going to go off. And there we are. So the burner circuit is energized, going through its safeties and so forth, and then that's an indication that this is detecting water. But as you can see, it's not anywhere near water. We don't even have it hooked up to a probe. We're going through this 150 ohm resistor. I think it needs to see about 10 or 12 ohms before it won't do the alternate blinking. Now, if you push this test button here, you got to hold it for a few seconds. Burner circuit goes off, water circuit goes on, and the power is then just flashing to let the system know that, yeah, it's really, we're in test. So this test button does not test the probe. It just tests whether the circuit is wired correctly and is going through the proper procedures. Now this is going to then stop, and the burner circuit is going to come on because we've got it set up as if it contains, the circuit is detecting water. All right, well, I hope that was helpful. Please ask some questions below. I don't know everything about these circuits, but I'm going to try to answer them together, and hope this helps you out in the field. Thank you very much. Take care, and safe steaming.